Hello and good afternoon, CTS266 Section 840 students for the Spring 2016 semester at Anne Arundel Community College. This is the Cisco Networking Academy CCNP Switch course, and this afternoon's video tutorial is going to be a nice, easy introduction into the Network Time Protocol, or NTP. Now, remember that we use NTP for a lot of critical tasks. Probably first and foremost is going to be from a forensic perspective when we look at logging, and can't stress enough how critical it is that we have accurate time being kept on all of our components to make sure that we have accurate logging and messages, so that we know if something's gone wrong, we'll know the time that it took place. So let's go ahead and dive in here, and this is going to be a nice segue. This activity will be a nice segue into Lab 7-1, where we go back into the full mesh configuration of the four catalyst switches, where DLSW01 is going to be the NTP Master. So here, during this setup, we're going to have router 1 synchronized to an external NTP server. And then what's going to happen is switch 1 and switch 2 are going to synchronize to router 1, but then they're also going to peer to each other for NTP time services. So let's go ahead and dive in here. The first thing that we're going to want to do is on router 1, we're going to make sure that router 1 gets set up to pull its time services from the NTP server. So we're going to go from user exec to privilege exec, and let's say show run and include NTP. So do we have anything set up? So nothing set up right now. In fact, if I were to say show NTP status, it would say NTP is not enabled. It actually says that on real Cisco switches and routers as well. If I were to say show NTP Associations, it would just simply give me the command prompt back, because unfortunately we haven't set anything up yet. So now let's get into global config, where we're going to get some work done here. So, I'm sorry, NTP server. If I do a question mark, you can see I could put a host name down if I had a host name statement that tied to an IP address. But we're just going to simply put in the IP address of the peer. So NTP server 209.165.200.187. Now, when I do the question mark here at the end, one of the words, or I should say one of the keywords we're going to talk about is going to be prefer. So if I had multiple NTP servers, I would want to prefer one over the other possibly. And so let's go ahead and say prefer. And we'll put a bogus entry in here. In fact, let's take a look at the NIST time server. So when you're dealing with time on the public internet, there's a number of places that you can go. And NIST is one of those. So as you see here, NIST has a number of time servers: time-A, time-B, time-C, and time-D. And as you can see here, time-D is providing time services for IPv6, or it has an IPv6 address that can be used, which would be a dead giveaway that you would be using NTP version 4. Remember, NTP version 4 is what gives us the ability to do NTP with IPv6. So we'll take 129.6.15.30, right? We just need another address in here. So 129.6.15.30. So now when I say do show run include NTP, you can see we have these two statements here. We've got the first statement, NTP server 209.165.200.187 prefer. And that prefer, again, that is the NTP server that if we have multiple entries, that's the one that I want to prefer. So we know that we're going to be setting switch 1 and switch 2 up. So the lab mentions NTP max associations, and you can see this is a 32-bit value here. So I could limit the number of NTP associations, and let's do that. Let's just simply say we'll throw a number out there. So 15. So I'm going to allow or limit the number of NTP associations to me, because I'll be serving as an NTP server here. I'm going to limit the number of associations to 15. So 15 devices or nodes could use me, router 1, as an NTP server. Okay, So now that we've got our basic NTP do show run include NTP, right? So that's how we're set up. Let's go ahead and say do show NTP status. So you can see that the clock is synchronized, and let's get our pen out here. So you can see that the clock is synchronized. Now, a quick note: in the real world, when you go to do this, it can take upwards of, I've seen it go as long as 15 minutes before it actually synchronizes. You see that we are listed here as Stratum 2, with Stratum 1 being the most reliable. And that's what the stratum numbers refer to, is reliability. So Stratum 1 would be our highest, and then I believe we go all the way up to Stratum 15, which we can check here if I were to knock that out. Say NTP Master, and there we go. Yeah, 1 to 15. So the stratum numbers are 1 to 15, with 1 being the more preferred, and then going up in terms of preference. So 1 is the most preferred, then it would be 2, 3, 4, and so on. You can see that who is our reference? Well, it's that IP address that we put in at the beginning, which is the IP address here for the NTP server that's out here. So we've taken a look. We've seen that we are synchronized. And so now let's step down here to step number 3 and 4, where we're just basically going to say do show NTP Associations. And again, it's nice to see we've got a broken entry here. So it kind of gives us a little visibility into what a broken entry would look like. So this 129.6.15, you can clearly see that it's in the init state. And it's never going to come out of that state because, again, there's no reachability from IOU to that address. However, the first address here that we see, we'll highlight that in green, that first address right there, that is a good NTP source. You can also see that from the stratum, it's listed as a stratum 1. And that's why when we say show NTP status, we are a stratum 2. And so remember that. Whatever the stratum number shows up, that shows up here with show NTP status, whatever that stratum number is, the source from which we're getting the time is 1 less than that. So if that said stratum 9, we would be getting our time from a stratum 8 NTP server. If it said stratum 11, we would be getting our time from a stratum 10 NTP server. So that's why the associations, that is who we're associated to. This is our NTP status. Okay, the asterisk, you can see that means system peer, right? And that's very important when you see that asterisk here. And then you've got the tilde, which means configured. So we configured that time source. And again, we see that we are synchronized. So let's go ahead and clear our screen here. And let's do a show clock, or a show clock. So there's the clock right now, and you can see we show, and the lab mentions this, that the Pacific Standard Time, that this is an IOU convention. By default, on actual Cisco devices, if I were to pull up an actual Cisco 1841 router here, and we'll just look at router 7, and if I were to say show clock, you can see that it shows UTC time, or universal time. And if I were to say show clock detail, you would also see that the time source right now is a hardware calendar, and we'll talk about that as we move along. So, but again, that Pacific Standard Time, that's an IOU convention, so to speak. Okay, so by default, NTP is going to synchronize only to the software clock. If we wanted to synchronize to the hardware clock, we would have to enter in the command NTP update calendar. So if I were to say show clock detail, you can see here that we're actually already updating. Our time source is NTP. So what we might want to do is we may want to change the time zone. If you're following along I'm just kind of rolling down here to step number 5. So if I were to go into global config and say clock time zone question mark, you can see word, and this is one of the things early on, you know, many years ago that kind of confused me, because you would see different conventions here, but all it is that you can make this say whatever you want. So I can say Eastern, and we'll say NYC, right? So that's simply the name, and again, I can make it anything I want. And then here, I put in the offset that we are right now from UTC. So we just had the daylight savings time here. So let's say, I believe we're -5. So we'll say clock time zone Eastern NYC -5. And time zone is up. It's limited to 7 characters. So let's drop back and say East in New York. So we'll do that. So Eastern New York time zone. So we've actually updated do show clock, and it shows Eastern time 1:27:04, or I should say 13:27, which is military time for 1:27. So you could put that in there if you want. And then what we need to do next is we need to say clock summertime to indicate what time zone, name of the time zone in summer. So again, we can use the same thing. I can say East_NY, and then we can say, is this, do I want to put absolute dates in, or is this going to be something that's just recurring all the time? Well, it's typically going to be recurring. Here in the United States, there's, I guess, in Arizona, I think there's somewhere in Arizona where they do not do daylight savings time, I don't believe. So, but again, we're going to go ahead and keep our time, and you can see that it actually looks like it might be syncing with the system. Do show clock. So 14:28:01. Yeah, so it looks like it may be syncing with my system here, possibly, or just very, very close to what's actually, yeah, so very, very close to what the system time is. And so, but it's displaying it sort of in that universal time code, even though I've said Eastern time. So let's go ahead and say do show clock detail. And sure enough, on March 13, 2016 is when it started, and we will fall back an hour on Sunday, November 6th, 2016. And so that's, again, when we fall back and it starts getting dark extremely early. And so the time source is still NTP. All right, so let's take a look real quick here, and let's say do show run section NTP. And that's what we've got. We've set the time zone, so we're good to go there. So now what we're going to do, because on switch 1 and switch 2, we have no time set up here on these guys. So if we go from user exec to privilege exec into global config, do show run include NTP, you can see that there's nothing set up. Do show NTP status, and we've got nothing. So what about a do show clock right now? Let's see. Yeah, you can see it shows Pacific time, 10:29. So, and they've got that PST in there, which again is an IOU convention by default. So let's go ahead and let me do a real quick check here. Do show NTP, or do show IP interface brief. All right, Ethernet 02.10.0.1.1 or 0.0.1 Ethernet 0.0. Okay, Ethernet 0.0. So yeah, so what we're going to do then is on switch 1, let's go ahead and say, let's point to the NTP server 10.0.0.1. And that's pointing to router 1. We're going to do the same thing here. We're going to set our clock time zone to East_New York. We're going to say it's -5. And then we're going to say clock summertime East_New York, and we're going to set it to recurring. So now let's say do show clock, and you can see that the time is updated. What about a do show NTP status? So our clock is synchronized, and there you can see, right, every sort of hierarchical level we go away from the original source, it's going to continue to increment by 1. So the clock is synchronized. The stratum for this switch is a stratum 3. So if I had another switch hanging off of this one and went to make this an NTP server, or an NTP Master server, that the time sources that its clients would see would be stratum 4. All right, let's go ahead and say do show, whoops, sorry about that, do show NTP Associations, and there we go. So what is the stratum from the source? Stratum 2. Now, ultimately, that is the ultimate reference clock, because that is where router 1 is getting his time. But this is who we are getting our time from. So we see who we're getting our time from and who they're getting their time from. And let me do this here. So now we're going to do the same thing on switch number 2. And then we're going to pair these guys together. So on switch 2, go from user exec to privilege exec into global config. Say NTP Server 10.0.1.1. And then same thing with the clock and the time zone. We'll say east underscore NY -5. And then clock, clock summertime for east underscore New York is going to be recurring. All right, so we'll say do show NTP status. So we're synchronized. Do show NTP Associations. And there we go. And it's master and it's synced. And the master is 10.0.1.1. They are getting their time from 209.165.200.187. The lab also talked a little bit about NTP design hierarchy. So a flat hierarchical model versus, or I should say a flat model versus a hierarchical NTP model. So flat is more stable. Unfortunately, the hierarchical model is more scalable and it requires less administrative overhead. And so typically with a hierarchical model, what you have is the time source coming in from maybe your core routers, and then that time is synchronized and used as the master for the distribution layer, and then the distribution layer simply points to the core, and then your access layer would point to your distribution layer. And so what we're going to do now is we're simply going to set up a peering between switch 1 and switch 2. So they're going to be peers of each other. And what that means is that they're going to exchange time information with each other, as well as receiving the time information from the NTP master that they're looking at, in this case switch 2 10.0.1.1. So it'll remove any single points of failure that we might have. So all we have to say is, let's pull this guy back up here. All we have to say is NTP peer, and his peer is 172.16.0.11, which is switch 1. And so now when we say do show NTP Associations, you can see that he would refer to, or should I say switch 2, would look at switch 1 in the event that the master NTP source were to go away. So we can actually try to force that here and see if it does what we expect it to do. So again, removing those single points of failure, 16.0.12. So we'll say show NTP Associations. Right, so now we have two sources. So show NTP status. Clock is synchronized, stratum 3. But again, the reason we're peering, right? The reason we're peering is so that we have another source, a secondary source that we could look at if the primary source were to go away. So let's come over here to router 1, do show run section NTP, and let's see what happens. We're going to say no NTP server 129.6.15.30, and then no NTP server 209.165.200.187. So do show run, include NTP. So all I've got is the NTP Max Associations, but I've pulled off the NTP server statements, right? So right now, the two switches are pointing to this router, but this router is no longer associated with any reliable source. Now, is that going to break things? No. So show NTP Associations. it's still just going to show that they're pointing to router 1. But let's do this. If I were to shut down, and let me take a look at the topology here real quick. Yeah, Ethernet 0, 0, and 0, 2. So let's go into interface Ethernet 0, 0 and say shut, and interface Ethernet 0, 2 and say shut. So we've shut those interfaces down. So now switch 1 and 2 no longer have visibility to the, and let's see, ping, we're going to have to wait for the polling time here. We're looking at about 64 seconds, 00.1. So can I ping my NTP server? I can't. Let's take a look over here on switch 2. Can he ping 10.0.1.1? And he cannot. So as you can see, we no longer have reachability to the primary NTP source. However, we do have reachability between switch 1 and switch 2. So what we're going to see when we do that show NTP status, after they drop the NTP relationship with router 1, they'll have a pairing relationship, and this is why we do the pairing setup, is so that if they lose that connection to the primary NTP server, that they have each other to rely on in order to make sure that their clocks stay synchronized. All right, so let's clear the screen here, and hopefully, let's see if, so it's still showing it there. Let me do this. Let's do a write mem, and we're going to say reload. So I'm simply going to reload switch 1, and it comes up pretty quick. I mean, you see how fast it comes up there. And let's go ahead and check here, show NTP status. So clock is unsynchronized, but a show run include NTP. So I still have these two statements for NTP server, show NTP Associations. All right, so let's give it a couple seconds here, because we've got the pairing statement pointing over to switch 2. So you can see that we've got two configured NTP time sources, right? And there we go. So VLAN 1 came up. My assumption is, and we'll give it a couple seconds here, is that we should see the asterisk on the pairing. And let's see what from switch 2's perspective, what does switch 2 see? Here, do show NTP status. So clock is synchronized stratum 3, and the reference is still showing do show NTP associations. Yeah, so it's still showing that it's tied to router 1. However, there's no reachability to router 1. And there we go. You see the change? It was right there. So who is the reference clock? So now when I say show NTP status, we're still unsynchronized, yet we are peering with switch 2. What about show clock detail? The time source is NTP because we are peering using the reference clock from switch 2, who's 10.0.1.1 and is a stratum 3 source. So again, show NTP associations, and then show NTP status. So we still show unsynchronized. So I would have to check to see when it's peering if it would show unsynchronized, if it's supposed to show unsynchronized when it's peering, or if it should. And we'll get a chance to look at this on real Cisco hardware, if it's just going to continue to show unsynchronized there. So it did update, right? It did show that reference clock for or who switch 2 is looking at, the 10.0.1.1, pointing toward, I should say pointing toward router 1. I think I said switch 2 earlier. But that's switch 2's IP is the 172.16.0.12, pointing towards router 1. So they're pairing with each other, show clock. And so they do still have those settings that we had put in there originally. All right, so this is just kind of an easy introduction into NTP. We're going to get into far more complex setups where we're going to be using some access lists and things like that in Lab 7-1. But for right now, this kind of gets us into the setup with NTP, and very, very critical that when you type show log, if you think you've got some sort of an issue, that your times that show up in your log are accurate. Very, very critical from an operations perspective that you know whether or not your clocks are active. All right, well, this is going to wrap up Discovery Activity number 12, where we were taking a look at NTP. All right, thanks for watching, guys, and I will see you tomorrow evening.